consider this code snippet written in Python. So you can observe here it is written as 0.1 plus 0.2, that is equal to 0.3. And in the next line, so for this, what do you think will be the output? Comment below your answer for both the lines. So for this you might write true, right? And for this you might write, let's say, false or true, right? So after the execution, if I execute this code, so you can observe here, for the first line the output, the corresponding output is false, and for the second one it is true. So what do you think is the reason behind this? Mathematically this seems consistent, but the output is different. So here comes the role of computer organization and architecture, right? So that is the understanding of data format, that how data is recorded in a system and how computer interprets the stored data. So based on that the results are compared actually. So first of all, let me brief on this and then I'll justify this part. So basically this part requires the understanding of data format, how instructions are decoded, how data is represented in machines. So these understanding will be clear when you study about the course of this computer organization and architecture. So this course covers the basic concepts of computer architecture and computer organization and computer design as well. So that can help the learners to have a clear view that how the computing system works. So it is not upon that the understanding of programming language, it's more about how you understand your computers, specifically the digital computers in better detail. So that's the idea. So the first fundamental question, what is a computer, right? A very lame question for most of the people. So it is a general purpose digital electronic device. I would say our today's computers are general purpose because we are able to do most of the computational task here. Digital electronic device that can be programmed, and if anything can be programmed, that will contain microprocessor, memory, right? The storage systems, IO subsystems, and so on, to process data and yield meaningful results, right? So that's the general definition of a computing system. Now let's try to understand computer organization. So it talks about the design of components and the functional blocks using which the digital computer systems are built. So if you consider a day-to-day job of a civil engineer, so a civil engineer's task is building various kind of building construction, right? So if you talk about during the process of building construction, a civil engineer has to decide which specific cement, right, bricks, iron rods, sand, and other building materials. So they have to specify that what exact raw inputs are required to build an entire system, right? So same for computers as well. In order to design a digital computer system, what exact components and which functional blocks has to be designed in which manner. So this is what we talk about under the course of computer organization. Now if I come to this computer architecture, so just like before a building is laid down, the blueprint is designed first of all, right? A blueprint is developed first of all. So computer architecture is analogous to blueprint of computer design. So how to integrate the components to build computer systems to achieve a desired level of performance, that's what computer architecture talks about. So if I talk about architects, so architects task is to design the or develop the plan of the building, such as the blueprint, overall layout, floor plan, etc. So that's how the analogy sits with architects. So now if I dive little more deep into the deeper aspects of this computer organization, so computer organization is concerned with the way the hardware components operate and the way they are connected together to form the computer system, right? So the various components are assumed to be in place, and the task is to investigate the organizational structure to verify whether the computer parts are operating as per the intended effect or not. So to give better detail, so I can say that organizational attributes include the hardware details that are transparent to the programmer, that which specific memory, which specific transistor, or which specific processor. So we get very specific to the hardware actually, such as the control signals, interfaces between the computers, and the peripherals and the memory technology that are used. So we are extremely specific, just like how a civil engineer is specific to what exact cement has to be used, which exact rods has to be used, what should be the specific diameter or the length of the rod, and so on. So it is an organizational issue that the instruction will be implemented by special multiply unit. So let's say I want to design a multiplier circuit. So it is the it is the part of computer organization where I have to decide that which exact components I have to take in order to design my multiplier circuit, or by a mechanism that makes repeated use of add unit of the system, right? So these are the organizational decision or organizational attributes. Now coming to computer architecture, so it is concerned with the structure and behavior of the computer as seen by the user, and by user mostly we consider programmers over here and the computer designers, right? It includes information, formats, how the data has to be formatted, right? The instruction set supported by a microprocessor, and the techniques for addressing memory. So this is what computer architecture is about. The architectural design of a computer system is concerned with specifications of various functional modules such as processors. So which all instructions the processor supports, right? What all memory operations are supported by the memory subsystems, right? And structuring them together to form a computing system. So these are the points regarding the computer architecture. Now, so computer architecture refers to those attributes that are visible to a programmer, right? So the attributes, these attributes have direct impact on the logical execution of a program. That means how fast or how slow the program execute, that is affected because of architectural decisions, right? Now there is a term which is used interchangeably with computer architecture, that is instruction set architecture. In short, we call it ISA. So the ISA defines the instruction formats, or the and next the instruction opcode. So like if I have an instruction, let's say 2 plus 3, so there plus sign, for the plus sign there is a corresponding opcode for that, right? And 2 and 3 are the operands. Then registers where the data or the instructions can be stored. Then instruction and data memory, the effect of the executed instructions on the registers and memory, right? So these are the components which are defined by this instruction set architecture. And it also talks about the algorithm for controlling instruction execution. So generally this instruction execution control is handled by the control unit, right? So control unit exact design specific details, that's the part of computer organization, but the algorithm that it has to follow while handling the program execution control, so that is taken care by this computer architecture. Now, so if I talk about the examples of architectural attributes, right? So this includes the instruction set, right? The number of bits used to represent various data types. So basically here, right? So like how this number, for example, for this the output came in this format, right? So what I can do is that just to show you this part here, if I can stretch it down and maybe I'll write here, let's say 0.1, 0.1 plus 0.2, and B I'll write as 0.3. So let me just debug this code and show you that how the data formatting might have been done, right? So I'll just start this next into the next step. Now I can clearly observe for this A, I'll just do it again. If I just debug this part, let's say from this part itself, if I debug and let's say if I go to the next step, so you'll get to see it is this A contains 0.3, and at last you can see here 4 is there, right? Now if I execute the next one, B will contain 0.3. So you can observe A internally contains 0.3 and then multiple zeros and then 4, but this contains 0.3. So when you compare this, hence the result come false. But when you go to the next one, this 0.4 and 0.1 represents exactly 0.5, and because of this the output comes out to be true. So you can see the output is true in this case, but for the first case it is false. So let me just execute once more and show you. For the first one it is false, and for the next one it is true. So basically data format, so one need to have clear idea of data format, how data is formatted, then you can answer this or understand these nuances in a better way. IO mechanisms and the techniques used for addressing the memory, so these are all the concerns of computer architecture. So why study? Definitely to understand the digital computer in a better way, how your memory works, how your CPU works, right? Arithmetic logic unit, registers, how the registers are organized, right? And so on. And because of this we'll be able to write better software, right? Now let us say there is a piece of code where this kind of statements are written. So in that case, the person who has studied computer system, computer architecture, computer design, computer organization in a better way, they will be able to handle such kind of bugs properly. So it allows the programmers to appreciate the relative cost of operations. That means while you're developing algorithms and all, if you keep this relative cost of operations in mind, then you will be able to write better software. As you can see the consequence in today's time, the data centers that are consuming so much of energy, power, electricity, water resources. So if your code can positively affect these things because of your knowledge of your computer architecture, so that really makes huge amount of impact for the society, right? Now in-depth understanding of internal working of modern systems, their evolution. And as a programmer or as a software or hardware designer, how can you decide within the trade-offs, how can you trade off within this hardware and software design boundary, right? Then you will get better insights into fast or slow operations that are easy or hard to implement on hardware. Then understanding of out of order execution and branch predictions, right? So these are the reasons. Then how programming languages like C++ and Java represent data under the hood, or Python in general, that I showed you here, right? Now, how programming structures are encoded into bits and bytes, so that understanding will be clear. How to efficiently manipulate and manage memory. So again, that part is also that is also served in this course, right? Now, the topics that one should definitely study at an undergraduate level is machine instructions and addressing modes, that how instructions are stored, how instruction addressing is done, how the data is fetched, and so on. Arithmetic logic unit, data path and control unit. Then instruction pipelining, it's one way of increasing the performance of the system. Then memory hierarchy, understanding caching is very important in system design interviews. Main memory, secondary storage, very very important for database systems, right? And in general for operating system as well. And then IO interface, that is interrupt and DMA mode. So these are the important topics that one has to cover as an undergraduate student or a learner, right? Now if you consider this one, this is a famous course page, or this is the software engineering interview prep guide from Google, right? So this is their official career page. Now if you observe here, if I search for the word memory, so you can observe in the interviews they definitely expect that one should have good understanding about this direct memory access, right? You can see here direct memory access, this part. Then access ordering, byte ordering, little Indian ordering, by okay, big Indian ordering, by Indian ordering, pointers, caching, right? Then storage, so in order to understand storage systems, one should have clear understanding regarding secondary storage. Only in that case you will be able to understand the storage tools in better way, right? Then low power management, again, because of architectural and organizational decisions, the power dissipation can be decided, right? So then while developing mobile applications, understanding runtime, memory, battery life, multi-threading and so on, right? So that is again important aspect for a software engineer or a computer engineer to understand the nuances of computer architecture and computer organization. Then understanding memory cache, right? Hardware cache, software cache, and so on. So as you can see clearly, it is something that is required in industry as well. So that's why I keep on saying to everyone that if you are a computer engineer, then this course is something which is non-negotiable, along with digital logic. And digital logic is the base for this. Without the elements of digital logic, if you try to understand these concepts, you will have definitely you will not be able to enjoy the concepts presented in this particular course. So very beautiful course. It is used in industry as well, and it is asked in interviews as well. So you can observe that in interviews, definitely the memory organization concept, as you can observe in this line, that as an as an engineer with computing foundations, you must possess a solid understanding of fundamental computing concepts, including process, thread management, concurrency, and the word memory organization. And memory organization and memory architecture definitely comes part of this course, that is computer organization and architecture. So I hope that I could justify this part, that why the course of computer organization and architecture is very very important for any computer science graduate.